students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as aromatic compounds. Let's see this. Now, what do we understand by aromatic compounds? Aromatic compounds, these are organic compounds containing at least one benzene ring in their molecules, right? So what are aromatic compounds? These are the organic compounds containing at least one benzene ring in their molecule are called aromatic compounds. Right, so these are aromatic compounds, right? Now when I say about benzene ring, what is a benzene ring? A benzene ring is a hexagonal ring made up of 6 carbon atoms containing alternate double and single bonds. Benzene ring. What is benzene ring? Benzene ring is a hexagonal ring made up of 6 carbon atoms containing alternate double and single bonds. Fine. Now, let's see the nomenclature. How does it look like? Name, and let us see how does it look like. Suppose if I say benzene, so you don't actually write the 6 carbon and atoms to show it. You just show it in the form of a hexagonal ring containing alternate double and single bonds. This is your symbol for benzene, right? Next, in this case, suppose if they ask you naphthalene. Naphthalene is 2 benzene rings joined together. This is your naphthalene. Fine, do we get this thing here? Next, suppose if I say chlorobenzene. What is chlorobenzene? Where you have benzene ring and chlorine attached to the first carbon atom. This is chlorobenzene. Then you have nitrobenzene. Nitrobenzene. What is nitrobenzene? When you have benzene ring and you have nitrogen dioxide connected to the first carbon atom. Then what is benzene sulfonic acid? Benzene sulfonic acid. This is going to be this way, SO3H. This is benzene sulfonic acid. Next, what is benzene aldehyde? Benzaldehyde. Benzaldehyde you have carbon and aldehyde, CHO. So O is connected here and H is connected here. This is benzaldehyde. Next, what is benzonic or benzoic acid? Right? Benzoic acid. Benzoic acid is nothing but same as benzaldehyde, except that instead of H you will have alcohol group there. So OH. This is benzoic acid. And next you have is toluene. You have methyl group. So these are the different forms of benzene that you can have. Right now let's find out the difference between aromatic compounds and aliphatic compounds. Difference between aromatic and aliphatic. Right? Now what are aromatic compounds? Aromatic compounds are those compounds that contain higher percentage of carbon than aliphatic compounds. They contain higher percentage of carbon than aliphatic. Right? Aliphatic compounds contain higher percentage of hydrogen than aromatic. Contain higher percentage of hydrogen than aromatic. Next, these are, as per definition, these are closed chain compounds. Aliphatic compounds, these are open chain compounds. Next, they are highly stable and are not easily attacked by acids, alkali and normal oxidizing and reducing agent. Highly stable and not easily attacked by acids, alkalis normal oxidizing and reducing agent. Normal oxidizing and reducing agents. Right? These are less stable and can be easily attacked by acids, alkali and normal oxidizing and reducing agent. Less stable and can easily be attacked by acids, alkalis and normal oxidizing and reducing agent. Right? Next, aromatic compounds burn with a sooty flame. Now, in case of aliphatic compounds, with a few exceptions, they burn with non-sooty flames. Burn with non-sooty flame. Right? Next, they have alternate double and single bonds. They have alternate double and single bonds, right? They have either single, double or triple bonds. Contain single, double or triple bonds, right? Now, the hydroxy derivatives of aromatic compounds directly attached to the benzene ring are acidic in nature. Hydroxy compounds, that means OH, alcohol group. Hydroxy derivatives of aromatic compounds directly attached to benzene ring are acidic in nature. Right? Whereas in the case of aliphatic compounds, they are neutral in nature, right? So I can say that hydroxy derivatives of aliphatic compounds directly attached to carbon atoms are neutral in nature. So one is acidic in nature and the other is neutral in nature, right? Now, aromatic compound undergo nitration very easily. Right? Aliphatic compounds do not undergo nitration easily. Do not undergo nitration easily. Next, aromatic halides are less reactive. Aromatic halides are less reactive. Aliphatic halides are more reactive. Aliphatic halides are more reactive. Right? So this is your basic difference between aromatic compounds and aliphatic compounds, right? Now let's see the structure of benzene. Now, who suggested the structure of benzene? The structure of benzene was suggested by a German chemist. His name is Friedrich August Kuehnel, and therefore this is also called as Kuehnel model. So Kuehnel was the first to suggest a sensible structure of benzene, right? So I can say that Friedrich August Kuehnel suggested benzene model. So the benzene model was suggested by this particular scientist in 1865. You could get this as your objective, right? Now, the molecular formula for benzene is C6H6. Fine. It is made up of 6 carbon atoms having alternate double and single bonds. Made up of 6 carbon atoms having alternate double and single bonds. Fine. Each carbon atom is again joined with one hydrogen atom by a single covalent bond. Each carbon atom is then joined with a hydrogen atom by a single covalent bond. So when you draw this, how would this look like? The structure would be this way. You would have 6 carbon atoms forming a hexagon having alternate single and double bonds, and each one of this carbon atom would then be joined with a hydrogen atom by a single covalent bond. Right? So this is going to be my structure of benzene. Fine, do you get this thing here? Now, it is not necessary I have the double bonds here. I could change my double bonds also. Right? That means I could have double bonds at the other places also. I could draw this, instead of this I could have drawn it this way also. Carbon, 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 carbon. I could take double bond, single bond, double bond, single bond, double bond, single bond. So my structure is not affected by the position of the double bond. Both are same, right? So this is going to be my structure of benzene, right? All the properties of benzene cannot be explained on the basis of these two structures. Hence, Kuehl suggested that the actual structure of benzene is somewhat in between these two structures, right? And the position of double bond is not fixed, right? Now, such a structure of benzene is represented I can say that all properties of benzene could not be explained on the basis of the above two structures. Right? So, hence Kuehl suggested that the actual structure of benzene, hence Kuehl suggested that the actual structure of benzene is an intermediate structure of the above two structures where the position of double bond is not fixed. Position of double bond is not fixed. Fine. Now, such a structure is also called as resonance hybrid. So he said that you could draw it this way. instead of drawing double bonds, you could draw benzene and draw a circle inside where you could have the double bond at any position, right? So that's my structure of benzene. Now let's see what is electronic structure of benzene. Electronic structure of benzene. Let's try to see the electronic structure of benzene, where you have 6 carbon atoms, right? There would be a single bond which I am showing by 2 electrons. There would be a double bond which I am going to show by 4 electrons. Single bond, you would have double bond, single bond, double bond, right? So those are my bonding between the carbon atoms. Now there is going to be a bond between carbon and hydrogen. So one electron will be given by carbon, one electron given by hydrogen. Carbon electron I am showing as X, hydrogen electron I am showing as dot. So you would have X and dot, X and dot, X and dot, X and dot, X and dot. So that's your electronic structure of benzene. Again here I could change the position of my single and double bonds. Fine, do we get this thing clear? Now, what are the physical properties of benzene? Now, benzene is a colorless liquid with a peculiar smell. Colorless liquid with a peculiar smell. Second, it is lighter than water. Then it is insoluble in water but soluble in organic solvents. It is insoluble in water but soluble in organic solvents, right? It is toxic in nature. Toxic in nature. Then it is highly inflammable and burns with a sooty flame. It is highly inflammable and burns with a sooty flame, right? Benzene solidifies to form crystalline solid. The melting point of benzene is 278.4 Kelvin and the boiling point of benzene is 353.4 Kelvin, right? So that's my melting point and boiling point. The specific gravity of benzene is 0.88 at 293 Kelvin. And I can say benzene dissolves in fats, resins, sulfur and iodine. Benzene dissolves in fats, resins, sulfur and iodine. These are the substances in which benzene dissolves. Now let us see the different types of structures of benzene, right? Let us see what are the different types of positions in which benzene can form a compound. This is very important. You need this in 12th standard again. What are the positions in benzene rings? right? Now let's assume that we're going to say that X and Y are, say, let us assume that X and Y can take place of hydrogen atoms. Let's assume that X and Y are two compounds such that I can replace hydrogen atoms by using X and Y. Okay. Now let's see the first position that you can have. You have 6 carbon atoms, right? You have alternate single and double bond, right? Now you have one compound X which is here, you have another compound Y which is here, and then you have hydrogen throughout. How do I count the carbon atoms in a benzene ring? The atom which is at the top is the first. You count clockwise. So in that case, this is the second carbon atom, third, fourth, fifth, and sixth. So these are my six carbon atoms. If you have a compound that replaces, or if you have an atom or a compound that replaces hydrogen atom attached in the second position, then such a structure is called as ortho structure. Or this is called as my ortho position. Fine, we get this in clear? This isomer is called as ortho isomer. Fine. Next, let's draw the benzene ring again. Single bond, double bond, single bond, double bond, single bond, double bond. X, hydrogen, Y, hydrogen, hydrogen, hydrogen. Right? I have the first and the third position that have been replaced. When the third position and the first position is replaced, then such a structure is called as a meta structure. Fine, do we get this in clear? And finally, carbon, 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 6 carbons, alternate single and double bonds.
So only the Y atom changes?
Yes, the X remains in its own position. X remains attached to the first carbon atom, and let's assume that Y is attached to the fourth carbon atom. Y
Every
is
time it will
attached,
start from the right only. 1, 2, 3, 4, 5, 6.
right,
As in
clockwise.
Yes.
Right, so these are my 6 carbon atoms. I've changed the position of Y atom to the fourth position, then such a structure is called as para structure. So you can have ortho compound, you can have an ortho isomer, or you can have a meta isomer, or you can have a para isomer. So if the two compounds or the two substitutes are in the first and the second position, then that is called as ortho isomer. So either it could be in the first and second position or first and sixth position. For ortho isomers, the substitutes in first and second or first and sixth position. So if the substitutes are in the first and second position or first and sixth position, then that is called as ortho structure, or it's called as the ortho isomers, or it is also called as the O isomer, right? If you have in the first, if you have the substitutes in first and third or first and fifth position, then it is called as meta isomer or M isomer. Okay, and similarly, if you have substitutes in first and fourth position, then it is called as para isomer or P isomer. Fine, do you understand this? This part is very important. How do you get the different isomers of benzene? Right? So there are 3 isomers. You can have ortho isomer, you can have meta isomer and para isomer. Fine, do we get this in clear? Okay, we will stop this here for the day. Thank you very much.